Welcome viewers in my MOOC course on optimization concepts and its applications. This video is on the topic of introduction to optimization. Introduction to optimization. Now, what is optimization? Optimization determines the best suited solution to problem under given circumstances. For example, a manager needs to take many technological and managerial plans at several times. The final goal of the plans is either to minimize the effort required or to maximize the desired benefit. Optimization refers to both maximization and minimizations. So, in a single word, optimization can be defined as choosing the best suited solution among the available solutions. That means there may be many number of solutions, but what solution is the best in terms of say effort, in terms of input cost, or in terms of output benefit from a particular process. And this optimization refers to both minimization and maximization. Actually, though this terminology is different, but in mathematical term these are basically same. What is that? Let me give you an examples. Suppose I want to find out a optimized value of a function f(x), function f(x). So, if this function say for this one, so these are the maximum value of this function. So, f max this one, and if I want the minimum value of the functions, if the function is something like that, so this one is basically minimum value of the functions. So, what is this? I can write down this function as a f(x) and this function as minus of f(x). So, in mathematical term I can write down max of f(x), maximum of f(x) is equal to minimum of minus f(x). That is why the optimization refers to both minimization and maximization also. What are the examples? Say for determining which ingredients and in what quantities to add a mixture being made so that it will meet specification with its compositions. Actually, this is an example, an alloy. You know, this alloy is made of several types of constituents, several types of basic elements. In what proportions if I mix this alloy, what proportion mechanical properties such as such as stubbornness, such as hardness will be maximum. And not only these mechanical properties, these properties can be any properties, maybe in electrical properties, maybe chemical properties, or allocating available funds among various competing agencies, deciding which route to take to go to a new location in the city. This is a basically transportations problem. We will cover these techniques in a separate video in later unit. Okay. And one of the most applications of optimization techniques is decision making. Decision making always involves making a choice between various possible alternatives. Suppose I am to machine a surface certain jobs, certain products, then what will be the different compositions of input parameters like speed, feed and depth of cut, so that I can get the best quality of the products in terms of say surface roughness, in terms of tool depletion or tool wear, in terms of minimum sound, in terms of minimum use of lubricants and so on. So, optimization is extensively used in decision making. Let me give you some decision making problem. The set of category 1, the set of possible alternatives for the decisions. For the decision is a finite discrete set typically consisting of a small number of elements. Say for example, a teenage girl knows 4 boys, all of whom she likes, and has to decide who among them to go steady with. That basically this is done with scoring methods. That means he knows 4 boys with some parameters or some qualities, say in terms of education, say in terms of service, in terms of handsomeness and so on. Now, based on optimization technique, he can choose which one is best. The category 2, the number of possible alternatives is either infinite or finite, but very large, and the decision may be required to satisfy some restrictions and constraints. That means there are various types of optimization techniques. Some types of classification optimization techniques is called unconstrained optimization and constrained optimization methods. That is nothing but unconstrained means the input parameters can take any value, and the constraint parameters is the input parameter constrained with certain limits. Say for it maximum value of these parameters is less than equal to 10. Then this type of optimization is called constraint optimization methods. Okay. Now, let me give you one example for optimization. Suppose a certain landlord, this is a river and he has just 2400 fencing and wants to fence off a rectangular field that borders a straight river, right. He needs no fence along the river obviously. What are the dimension of the field that has the largest area? Say for example this one, say this one is 100 and 100, and if it is so out of 2400, so this one is 2200. So the area of this one 100 into 2200, so this one 2200 square feet. The same fence, if I do like this, you see this one is 700 and 700, that means 1400,000. So, this one is also 2400, and the area is 70,000 square feet. Same thing if it is 1000 and this is 1000 and this is 400. So, the area will be how much? Area will be 4 lakhs. I think it is also 7 lakhs, it is also 2,20,000. So, though the length of the fence is 2400 feet, the depending upon the length and breadth, the area changes. So, what should be the one of the optimization technique? What should be this length and what should be this length? Then the area will be maximum, and the constant is, say for example, constant is y and say for this one is x. So, I can formulate this problem as area is xy and constant is I can formulate this constant is 2x plus 2y must be it should be x plus 2y x plus 2y sorry it is x plus 2y will be is equal to must be is equal to 2400 and what will be the A max value? Okay. What will be the A max value? In this lecture what we have covered? We have covered what is optimization, what are the different broad categories of optimization. One is scoring methods and another is basically optimization methods. Optimization methods with constant and unconstant parameters, and the application of optimization basically on decision making. I have explained what is optimization with one examples. They say very simple examples, and this type of problem in later videos, this type of problem we will solve. I invite you to learn optimization more extensively, more elaborately in the next video. Till then, goodbye.